All right. Well, it's 9:30 here local time, and it's time for us to start. So, thank you for showing up on time, staying up late, getting up early, whatever it is, and coming to the TLS working group. Welcome. This is the note. Well, it's Tuesday, so you may or may not have seen it. Basically, if you're participating here at the IETF, you're going to follow the rules and procedures, and that covers everything from IPR to code of conduct. Here's a bunch of rules about them. If you have any questions, you can ask us, area directors, other people that have been around for a long time. Uh, the I guess the gist of the IPR policy is if you know something, you got to say something, and the code of conduct is treat everybody with respect. Note really well. This is the virtual meetings, mailing list, and again, this is back for the professional collaboration kind of stuff. These should start to look pretty familiar because it's the template slides. Meeting tips. Please make sure to log in with the on-site tool to make sure that we get our appropriately sized room. This room is massive, and we're about a quarter full. So I don't know what that means, but we're all comfortable. Yeah. Yeah, 10%. I'm being corrected. So we're very comfortable. Nobody has to rub elbows if they don't want to, and that's all great. But it's also the way we're going to manage the queue to allow people, because we have a bunch of people we know that are remote. So that's how we're gonna manage the queue. So make sure you use the on-site tool so you can get in and get out of the queue. Yeah, make sure your video is off and maybe wearing headphones if you're in a noisier place. And if you are presenting, we'll offer to share the slides. But if you want to do that, you can do that as well. Some more resources that I'll let you read at your leisure. And then here's our agenda, which we published. So we're going to do some working group updates, talk about some of the drafts that are around. We may or may not get updates on some of them, but we thought we'd at least try to go through them. And then we're going to get to non-working group drafts, which are looking for some kind of input, maybe adoption, maybe not, but we'll go from there. And that's it. And I guess we should have done some introductions. My name's Sean Turner.
I'm Joe Salloway, and in the on virtually we have Deirdre. You want to say hi?
I'm also here. I'm Deirdre Connolly.
Awesome. Cool. Thanks. Again, thanks for getting up early. All right. So without further ado, let's get to the 8446 bis and 8447 bis.
Sean?
Yes?
Can I ask you to speak more into the mic? We're really far on this side. We have trouble hearing you.
Yeah. Okay. Can do. I can eat it. It tastes so good. So for 8446 bis, the document has been through IETF last call. It basically needs to. We had a bunch of changes. The thing that's holding it up right now is me, unfortunately. There are 38 reported errata on 8446 bis that we have to do something with, I think, before we give it to the ISG. Because if I was on the ISG, I'd be like, what are you doing with those? And the ones that we've looked at, a full quarter of them, maybe a third, are completely addressed, just adopted. There are a couple that got adopted but tweaked, and so we have to figure out how we're going to answer those. And there's a couple of other ones that I don't know what we're going to do with. So we're going to try to dispatch those before we move them forward. And then 8447 bis, Joe and I are authors, and so we're getting Deirdre to run the working group last call, and that's going to kick off the not too distant future. So that's really it, unless anybody has any questions. I like Eric's suggestion for the errata. Select all, hit close. That might be some of them, because some people use the errata process as a way to comment on the draft, and that's not really what you're supposed to do. So, but we'll get that fixed. The ECH update it's in last call. So that's really it. The discussion has been, I would argue, robust, and the authors have been well engaged. So I think we're progressing forward. And so it's going to end, the working group last call will end at the end of this month, I believe. And then we're basically going to try to progress it forward unless we have anything crazy that comes up. And Ecker.
Yeah, certainly not here to present anything crazy. I just I went to the issues list and the comments, etc. I don't see anything that I've seen. I don't see anything on the mailing list or in issues that looks like a problem to handle. So, assuming nothing comes up, I think we should be fine.
Yeah, I mean, so to be clear, right? Most of the nudges I've been getting is why is it taking so long, but you've been kind of all over this last call. So I think it's mostly about um, timely responses, and that's been great this time. So unless something crazy comes up, we're going to proceed forward and be giving this off to Paul for IETF last call. All right.
Or
next is
Deb.
or Deb. I think it's going to keep being Paul. I'm not sure. They didn't tell us. In any event. Okay, so the next person up is Rich Saltz. We want to do this because we have designated experts. As you know, we lowered the bar to get code points on many of our registries, and sometimes things pop in there that you might be surprised by. So we thought it might be neat to have them come and give us a quick update about what's been registered since the last time, just so you're kind of aware. All right, let me find the slides.
See, I did that gracelessly so you all can look better than me trying to climb up. Yeah, okay, sorry. All right. Yeah, so this is an update since the last time, which was just in the minutes. Sabrina Tanamal is basically the ANA person who nudges us when we don't respond quickly. And so I say, hey, what happened since last time? And I get this diff, changelog diff. So all credit to her. Next slide. The experts, me, Nick, here, yep, there's Nick, and Yov Near. The rules say 2 out of 3. There we go. We still have not rejected anything. Interestingly, people know not to ask for bad things, I guess. The change to 8447 bis will require this. I think we're working around the language that the TLS working group knows about somebody doing things to define a crypto protocol or consensus or algorithms. I'm not sure what the requirement will be. I don't think it's fully well written down yet, but still an open issue. But the intent is things that are open to the public, like ALPN, exporter labels and stuff. Those are, anybody can still do one of those. Next. So the chain extensions. Yeah, Ecker.
So maybe I misunderstood what the intent. Can you go back to the previous slide? I didn't think that I thought that the intention here was only that things shouldn't be like concurrently up for standardization somewhere in IETF and we don't sign off. Like I thought the idea was if I wanted to do if I have minutes of newest to curve and I just want to get the code point and I'm not doing anything on IETF, then I don't need working group %. But that what we shouldn't have is it being in like CFRG or an IPsec or something like that.
That could well be right. The wording needs to be fixed to make
okay.
one way or the other.
Okay, let me take a look because that was certainly not the intent. That
Okay,
when I was complaining about this, that was not my intent. I'll take a look at the draft. Thank you.
All right, thanks. So the Ecker's intent. The intent is if it's standardized in the IETF, it should go through. The TLS working group should at least know about it. If it's an IRTF or somebody else wants to say, "Oh, here's my new fancy brain pool plus curve," that should be allowed. So I think the fact that he and I disagree on what the words means that the words got to be fixed a bit.
Martin.
Yeah, so my understanding aligns with what Echo said, which is if you're bringing something to the TLS working group and asking for a code point, that's not cool. The TLS working group should be making the call at that point. I think it's still okay for other working groups to produce TLS related things like LPNs and exporters and those sorts of things. But again, the same rule I would expect should apply there. If you're taking it to an IKE working group or something or other because they need something, then talk to that working group as well. But I mean, this is just guidance at that point.
Yeah, agreed. So the wording needs to be fixed a bit, no surprise. Extensions. So last time we had said, oh, we're about to issue this extension. And then like the various other SDO chairs got involved and it was premature. So it was withdrawn. It wasn't rejected, it was withdrawn. DTLS has returned routability checks. There's a new extension. And then there's a ECH has two other identifiers for, the encrypted client hello, inner and outer message, hello message.
I guess I can add that this is Sean Turner. I can note that I guess I talked with Hannes, and he saved him from getting up. There's now multiple implementations ready to go. We kind of paused moving that document forward. So once I get confirmation that there's 2 interoperable implementations, we are going to release that document so that it can go off on its merry way. So
You know where to find us.
Yep.
Next. Nobody registered any cipher suite signatures, groups, etc. ALPN. So there's one that's actually not in progress. The COAP ALPN identifier was clarified to be COAP over TLS because now they have COAP over DTLS, and so that's CO. The AP got lost in transit. And there's no new crypto exporters. So it's kind of boring quarter, I guess. Next.
and that's it.
That's it. Okay.
Yep.
There you go.
All right, cool. Okay. Scott, did you send us slides? Great.
Extremely quick update on the TLS hybrid draft. It is mostly unchanged. The only thing okay, sorry. Oh, yes, thank you. It is mostly unchanged. We reduced the number of groups down to 2. MLChem 768 plus X22519, and same with P256. The only 2 issues that I'm concerned with is waiting for the final FIPS FIPS so that MLChem is official. We can't really release that until it's there. In addition, the ongoing controversy about how do we actually combine the shared secrets. TLS has a very robust key derivation logic, so we figured that concatenation is good enough. Other groups want to do something more robust. We would just like a decision. Thank you.
Deirdre?
Where's my camera? There I am. For the 2 cipher suites that both rely on what we used to be called Kyber, I'm not sure if they've both updated their definitions to explicitly say MLChem yet. They both seem to be named Kyber and things like that. Can you confirm?
I do not recall at the moment. We could update it to say MLChem draft.
Okay. On your second point, it doesn't matter for TLS 1.3 because TLS 1.3 key schedule is beautiful and deserves, ponies and rainbows and puppies. TLS 1.3 can get away with just concatenating these 2 shared secrets, and we're basically done. We are blessed in that regard. So all the other things, including the thing that I'm a co-author on, X-Wing, that are kind of generic hybrid chems, basically TLS 1.3 can afford them. We can get away with the extra computational work that's happening inside them. But because TLS 1.3 is already hashing in all the public information as part of these chems, either way, it's not strictly necessary for TLS to also consider them. We can basically consider them because we are happy and generous and can get away with it. So that's kind of my opinion.
Okay. Agreed with that.
All right, we got a queue. We got Martin and then Ecker.
Yeah, Martin Thompson. For the reasons that Deirdre just pointed out, I'd prefer not to wait on the controversy. If the FIPS certification comes in from MLChem and we get a final approved thing, we can ship. And if the controversy has resolved at that point, then of course we may want to have a discussion about that, but we don't have to wait for them.
Ecker?
Yeah, I think I largely agree with what Martin just said. I think there's, people want to get this deployed. I guess I'd like to hear from perhaps to see Stephen in the room, maybe from Dennis, if he's around, like what people's plans are for deployment now. I understand Chrome's already doing something, like what code point are you using? What does Firefox plan to use? It'd be nice if there's people already using if these people are already using a code point for this spec, then we're already effectively have shipped whatever else we do. So I think getting this out the door is a feature. And the only question is like, at what point do people feel like they're ready to start shipping code?
All right, and right after you is Dennis.
One comment about that: if NIST does make a final change between the draft and the final version, we're going to have to change code points anyways.
Yeah. We just drop the code points. I don't think there's a problem.
Hey, yeah, just a quick update on the implementation side. So I think Chrome announced today that they're going to release after a reasonable amount of experimentation with the existing code point and the existing mechanism. In Firefox, we're shipping it in nightly currently, and we're looking to do it in release, fairly soon, but no concrete timeline at this moment.
Okay, that's it for the queue.
Thank you.
All right, Joe, you're up. All right, so now we're going to switch over to talk about a draft that's been around for a bit. Confirm my selection. There we go.
All right, so this is for the obsolete key exchange draft. Next slide. Let's see, we've completed working group last call. We're kind of stalled on chair actions because we're also working on 8447 bis at the same time, which adds this new state for the registrations, which is discouraged D. So we need to make sure that that the current key exchange obsolete draft aligns with that work. So next slide. There's a couple of things. I put some proposals here in that looking at what the draft currently says, what the key exchange obsolete draft says. For example, for RSA, it's a must not in TLS 1.2, doesn't apply in 1.3. So that sounds like it would map to a discouraged. Same thing for finite field FFDH. Then with ECDH, we have should not. And in that case, I thought that might be an N or a not recommended, which is perhaps a little bit less of a deprecation there. And then for FFDHE, also, this was a little mixed because in TLS 1.2, we say it's a must not. And then for 1.3, we say it's a may. I thought that would map to a discourage. But that seems to me to be one that we probably need to discuss a bit more because we're saying it's okay at 1.3. So maybe it's not recommended or recommended with some note. I don't know if anybody has any comments on these now. If not, this will go to the list at some point.
Martin is getting to the microphone.
Yeah, I think because we put FFDHE in TLS 1.3, I'm probably leaning more towards the N side rather than the flat out don't do that. But ECDH, we should just say no. The static ECDH is just not good practice.
So when you say no, you think it should be D?
D, yeah.
Yeah.
Like, do not.
Okay, thanks.
Rich?
It's the long walk.
Yep.
Dead man walking. Yeah, I think it's kind of not a good look if we say deprecate for something that just came out. It's currently the most recent version. Maybe change it with 8446 bis for the FFDHE. In 446 bis you can, but on the other hand, they're probably going to be tied together, right?
Well, I think, yeah. So you're saying we should either change it to in 8446 bis to be not recommended there,
Yeah.
or leave it as N here. And because right now, I think, yeah, looking at this, it doesn't make too much sense the way I have it written here. So
Right.
it should probably go to either N or D. I mean, it should map to what happens in
Yeah, the
8446 bis.
The two should be aligned because they're going to be published at the same time, and we should have not conflicting advice. And I don't have any opinion as to whether it's an N or a D.
Okay, perfect. Quinn?
Hi, thank you. Quinn Dang Agnes. I think the must not for the FFDHE is a little too strong. It depends on the group size that we are talking about. If you do, so it depends on the group size. And in generally say must not, that means must not for all is a little too strong. As long as in classical security, if you have the big enough group size, then FFDHE is fine. It's just slow on the computation compared to ECC, but that's all.
Okay.
So Martin Thompson, FFDHE in TLS 1.2 is kind of busted, which is why the must not exists. In TLS 1.3, we specify it, and we have named groups and that sort of thing, and they're all of a reasonable size, and it's probably okay to use modulo the computation cost. So there's a bit of a difficulty here with this being in a table. I would say in TLS 1.2 we should be discouraging it, but in TLS 1.3 we should be simply not recommending it.
Yeah,
if
right.
that's at all possible.
Right now, we don't differentiate in the IANA registry between 1.2 and 1.3 and this column. And
Right.
I don't know that we want to do that.
I don't think we have to.
Yeah. Okay. Thank you. I think.
All right. Ecker or David Benjamin? Somebody, no, hold on.
It's me and then. Oh, go ahead, David.
No, it's okay. I guess I took myself.
Yeah,
Okay.
why don't you go? That way queue's clean.
Sorry, I got very confused by the queue for a moment. On them being the same as in the registry, the FFDHE and TLS 1.2 is just called plain DHE. They're like different cipher suites altogether. So we actually don't need to do any work to differentiate them. We just like say that the DHE cipher suites are bad because of all the reasons Martin mentioned. And then the FFDHE groups in TLS 1.3, we can say whatever we like with them, and they're pretty disjoint.
Thank you. That actually solves the problem that I was concerned about having to like split make another column. So I think that seems like a good solution. My impression is yeah. Thank you.
Okay.
All right,
I think we're good there. All right. The next thing is one thing that's not mentioned in the draft because it's maybe not strictly key exchange, but it does impact the key exchange when you're doing static Diffie-Hellman. And we currently have these marked as N as not recommended. The question is for these certificates that contain static Diffie-Hellman parameters that you would use in one of these key exchange schemes to do static DH, which I think we don't really want to do. Should we be deprecating these, or should be discouraging these, or just leave this out of this draft? If anybody has a thought there, it seems to me that we should probably discourage these.
I saw at least one thumb up.
Okay.
All right. I think we're going to try to put it in the draft. And
yeah. I think we'll move forward on that and take it to the list. Thanks.
All righty. What is next? Okay, Deirdre, you're up. Do you want to run the slides or do you want me to do it?
Give me the slides,
All right.
please. I don't see the button that was available last time, maybe because I'm a chair. Let's see. Share slides?
Yep. Oh, I can stop sharing mine and you can do them.
Oh, okay. Hold on. Where are they? Where are they? There they are. I'm back, friend. They're not over here. They're over here. Please. This will be fun. Let's see. All right, this is formal analysis, right?
Yep.
All right. Just this one.
Something's coming up. There we go.
How does that look? Good. All right. So this is a proposal of trying to slightly formalize how we get some sort of triage for formal analysis for changes to especially TLS 1.3. I say especially TLS 1.3 because 1.3 has had a lot of robust security analysis in its lifetime, especially compared to previous versions of TLS. And we basically don't want to degrade the beautiful shiny thing that we have inherited over time, because the only protocols that don't change are the ones that aren't used by anyone. So this is slightly motivated because of the changes included in 8773 bis, which went to a working group last call, but there were kind of concerns that it hadn't received formal analysis, and then the working group last call finished and it still hadn't gone required analysis, and then we're kind of left twiddling our thumbs about like, so what are we doing about that? And we're all just kind of looking at each other and just kind of shrugging. And so I had brought up the changes in this document in its discussion about some completely other matter with Douglas Stabila. And basically he kind of offhandedly was like, oh, that changes a lot of the fundamental security assumptions of several pieces of formal analysis that were done on TLS 1.3. And I was like, oh, I would not have seen that just by looking at these small changes of including the pre-shared key auth and certificate-based auth, which is basically the meat of the changes. And so that basically brings me to the suggestion of a triage panel, not a formal methods strike team, I guess. I wrote this up on the list, but to summarize, I think we can get some meat out of doing something a little more formally and a little bit more explicitly and a little bit more kind of encoded to our regular TLS WG processes of when we have something new, we kind of run it by a group of experts who have experience analyzing TLS or things like TLS, who may or may not have had experience with them in their research of analyzing it with formal methods tools like Tamarin or ProVerif or EasyCrypt or whatever else, but not necessarily. And basically ask them, as a document approaches a adoption call, do you think this needs formal analysis, updated formal analysis? Do you think this needs, what do you think? What's your smell test? And including their feedback as part of the adoption call. So the chairs would have our little list or little mailing list of people. I've gotten some tacit, buy-in to the idea from a couple of people. And we would run it by them, and then we would collect their feedback and bring it to the list as part of the discussion of the adoption call. Some of the things that we may get out of them is, yeah, this is fine. I don't think it needs any analysis. I don't think we need anything new, which is great. That makes everyone's lives easier and makes us feel more confident. It may include, this is very in line with previous kinds of analysis. It may involve the Tamarin model. It may involve a ProVerif model. It may involve something with meat behind it, an artifact behind it that they can build on. And they can give a recommendation of how to proceed and a scope of work. And then that can be part of the adoption call discussion. They may come back with, oh, this changes things fundamentally. this change to TLS would imply a significant new chunk of analysis work. This is going to be big. This changes a lot of assumptions. This is going to be a piece of meat to bite off in terms of our understanding of the security properties, even if the specific changes in like the protocol document or, the specific changes recommended may be small, which is kind of what the one I mentioned earlier kind of looked like. So all of that is part of the output of kind of the first phase, the actual triage that we would solicit, and then we bring it to the adoption call. So the working group, as part of the adoption call, could say, do we need this? This is a ton of work to actually look at, or this is an easy win. Like, this does not require a lot of analysis. This seems like a big win. Let's just go for it. Like, that can be all part of the discussion of the analysis. And then at this line back here is basically, we may adopt something, and then in the process of it kind of evolving as part of the working group, it's about to come up for last call. And it's changed significantly from when we first discussed it, and we said, oh, this is fine. We don't need any formal analysis. But by the time it comes to a last call, we might take a last chance look at it and be like, is this still the thing approximately that we said however many months ago that did not require formal analysis? So this is sort of the last chance for us to go back and just be like, do we think this is changed, significantly skewed? And just in case, because, for example, I worked on Frost for several years. It changed significantly between the thing that was adopted and the thing that was actually went to the RFC editors. That's CFRG, but still, those things happen. And then, so this is part of working group taking in this feedback and deciding what to do with it. My suggestion would be, if we adopt a document with the understanding that formal analysis should be part of this work as per recommendations from this triage panel, it would be blocked from going to a last call until that formal analysis is completed. If we say, no, we don't need formal analysis for this, then we don't, but we still have that last call just to double check that we didn't change it significantly in the meantime. And then for who is part of this expert panel, we can do regular refreshers at will. We can do it with a regular kind of check-in at every IETF meeting or so. I'm up for suggestions, but I have a short list of people with names you all know, and they've tacitly said, like, sure, like, why not? Like, and I basically lured them with I will give you and your students some free research ideas if you, kind of help us out. So I think this would not be too difficult to get some people in who would be willing to participate. And then what is the formal analysis that we care about? I think a lot of people, when thinking about formal analysis for things like TLS, they think of Tamarin, they think of ProVerif, they think of, symbolic model analysis using formal methods tooling. But that's not necessarily all we care about. We really care about kind of like a expert eye from a cryptographic eye, from a cryptographer, to just give like their smell test of like, oh, this changes your assumptions of your security model. This changes your assumptions of, if you have a game-based proof, or, this, or nothing changes. This is completely in line with all of this literature that we're aware of formal analysis of various types of TLS, and specifically TLS 1.3, or the components that are going into these changes. So the recommendations from this triage panel may involve updating a Tamarin model, or doing a new model with a different kind of computer-aided cryptography tool, or it may involve pen and paper proofs, or it may involve nothing at all. It may involve a line that says, these people looked at this and said, this is fine and does not require anything new. So that's kind of why I'm being very specific that this does not necessarily mean we're using formal methods tools. We may, per recommendations from a panel of experts. And I think that's it. That the goal is to maintain our high level of assurance, and this is one suggestion. So I welcome thoughts.
Right. We got a 6 or 7 deep queue. Can you see the queue and manage it?
Let's see. I will try. Scott Fleur.
Yes. Scott Fleur, Cisco Systems. It occurs to me that it may not be sufficient just to make sure that new additions haven't broken things, but whether or not those actually achieve additional goals. the thing I'm going to think immediately comes to mind is the extended key update. It's the way it's implemented is almost certainly not going to break existing security because keys has already been generated and everything, and whatever new keys are generated will probably be secure. However, that's not the only, that the whole point of it is to generate some sort of PFS, perfect forward secrecy. And it would occur to me that to make sure that you have that, that would require new analysis. So is that on the table?
Oh yeah, like it's definitely here is a change or a new suggestion. We want to maintain the security properties we have already established and rely on, and check that new assumptions do not need to be included. Or if they do, we do new analysis, including those new assumptions in scope. And if we're trying to add some new notion or trying to establish some new notion via a new mechanism, that is actually being held up. So I think that's totally in scope. Yeah. Eric?
Yeah, this is a great idea. I think it's absolutely fantastic. I think we should absolutely have like strike team jackets, and it should definitely be called a strike team. I think this point, I agree with point Scott just made about like verifying things do what they say in the tin. That was obviously important for ECH as well. We were pretty confident ECH wasn't going to break anything because we designed it, but like we weren't at all sure it would do what it said in the tin. In fact, you may recall some early analysis showed it didn't do what it said in the tin. To get ahead of something I think Stephen's going to say later, I am perfectly fine with having work blocked on someone's students. The bottom line is we shouldn't do things that we don't have confidence in. If we can't like round up anybody who's willing to review it, then that means it can't really. I suppose it's not very important. And to that end, I think if I make one small change to this or suggest one, I think that like the working group should make an explicit decision on whether or not things need formal analysis at the beginning of a working group acceptance, while taking the triage panel, obviously into very strong consideration. And what I mean by that is like the triage panel says we don't need it. I think it should be an open question whether we still need it.
Right.
And if the triage panel says we do need it, we really shouldn't be overriding them without a very good reason.
Yep, I agree. It's not binding. It is a input to the working group's decision.
Anyway, thank you for recommending this. Is a great idea.
I'm going to go ahead and lock the queue.
Jonathan?
Jonathan Hoylands, Cloudflare. I'm one of the people who did the Tamron analysis. I'm going to disagree with Scott. I actually think it does break the extended key update thing. I think it does break well, at least breaks the Tamron proofs. Not in a way that's not quite easily fixable, but it does break the current proofs. I want to ask a really annoying question, which is what counts as done? So several times I've done an analysis and then I try and get it published and it gets rejected because it's like, you found it was all good. We thought it was all good already. And then no one will publish it because it's not novel enough. So that's like, that could end up blocking stuff if we say it has to be published in a peer-reviewed journal or.
Oh, that's interesting.
So
okay.
And then, so this leads me on nicely to plug my research group, which is UFMRG. The Usable Formal Methods research group is hopefully going to be a place where we gather the kind of people who would be on this kind of panel. So we should at least work with them, even do it with them, whatever. Do I have other things on my list? Oh yeah, and blocking on students is, students are really slow.
Yeah, they are. So there's kind of the two phases that I had in mind, which is one, the triage, which I think is valuable, period. Even if we kind of have to draw the rest of the owl of how we actually get the formal analysis, even the triage bit on its own would be valuable. The second bit is leveraging the triage panel and anybody else to say, okay, is this a big scope of work or a large scope of work? Do you have someone? Do you know someone? That.
Sorry, we lost you for a minute there.
Are you back? All right. Well, let's see if we can go on. David, do you mind? We'll see what happens if Deirdre can get back on. We just want to at least get your input, David. Thanks.
David Skenazy, security enthusiast, I guess. Some days. So I think there are two parts to this. A first part is about, oh, Deirdre's back. Keep going. I'll make my point afterwards.
Okay, thank you. I blame MeetEcho. The part about trying to find out who will do this formal analysis and like pin a timeline to them and say like, hey, you promised this thing for us and like this is blocking IETF work until you get this to us. That is kind of left us to us, the working group, the chairs and the panel to try and be like, okay, can you recommend them to get this done in a reasonable time frame? And we can figure out what a reasonable time frame looks like. That may involve a little bit of growing pains, but like mentioning these sort of like carrot of like, here, if you want to train up your grad student on how to use Tamron or how to use ProVerif, and it's literally like a tweak to an existing well-known protocol, I think that we could find some decent useful
Synergy.
some synergy, that's a better word, useful grad students to do this for us. And then a different thing that I think Jonathan mentioned was, do we require publishing these results? And I say no, mostly because we find value in e-prints that never get published anywhere. We find a lot of value in just things thrown up on ePrint, and maybe they get published in a venue, like a conference or a journal or something like that, and maybe they don't. That's not necessarily the value that we are looking for. If it's peer reviewed, even better. But for us, it's trying to leverage the skill set of people beyond our skill set to look at these things that we're proposing and say, like, can you give us a due diligence, either with just like pen and paper formal analysis or using more, heavy duty tools like formal methods, to give us more confidence that we're not breaking the world and the things that we're trying to do aren't just completely based in nothing burgers.
So yeah, my final comment is I think this is actually a good idea in general. So let's do it.
Cool. David?
Hey, David Skenazy. So the two points. The first half, I think part of this is outreach. This is, in a way using the name of the IETF and the TLS working group to lead researchers to do research because they could get some recognition. So that 100% supportive of. I think, we should do more of that at the IETF. Do it. The flip side, where and not everyone, I think, agrees on that part, is how does this fit into our process and in what ways does it become blocking? And so I think if we have researchers working on something and they tell us, oh, we're almost there, or even more specifically, if let's say they come up with a bug, let's discuss that. Let's definitely look at it. What I fear is the propensity for deadlock. And so in particular, I can't really see how blocking something like this would be a good idea, and even how it would be somewhat allowable by IETF process. Like if I were to walk up and say, I'm looking into your protocol, please wait 4 months and I will let you know if I'm okay with it. You're going to tell me, that's cool, David, go somewhere else. And that researcher or myself, they're definitely way more qualified to say that than I am, but we're on an equal footing here at IETF. And so I think bringing them here, getting them to do their work is absolutely amazing, but I would really caution against anything blocking, because like we said, if a student gets distracted, we don't want the work to stop. And similarly, from a process perspective, I don't see a way where we can make that work in the way the IETF operates.
One suggestion being, the working group will decide if they want to basically adopt something and block it on formal analysis. But also, I think there's an obligation of the document authors and probably the chairs, less so than the working group, to basically like keep on it within conference with the people who are working on the formal analysis. Because in the ideal world, they would go off and try to start modeling it, either pen and paper or with a tool or whatever. And then they would come back and have questions like, what about this assumption? Did you answer this? And then the authors would say, didn't think about that. Pick something. It's going to be a back and forth between the people analyzing and the actual authors in an ideal world. Actually, in an ideal world, it's easy peasy and no one needs to talk much about anything. But in a case where you're actually doing a meat and potatoes analysis, it would be a back and forth. It should not be a throw it over the wall, we'll see you in 6 months, and then you give us a result. I don't think that's the way it should work. And if any of these kind of procedures trend in that direction, I think we will kind of have to jump on them, and it's probably going to be a responsibility of the chairs to basically be, like, hey, like, this is a team sport. We're working together on this protocol, including the analysis and the design and the specification. What's going on? And if like we have 3 meetings a year so that we can check in on the progress of how is the formal analysis of this thing that we, the working group, said is important to the progress of this document when we adopted it.
Great. Then that sounds great. Thank you.
Hi, Stephen Farrell. So I think it's a good idea. I'd echo what Jonathan said, that as the other co-chair of the UFM research group, that we're trying to figure a way to get these, to get some benefit in both places would be really good.
Yeah.
I think it's entirely feasible that for some piece of work, the working group might have consensus that yes, we should block on formal analysis. We've done it before. It's fine to do that again. I don't think that's okay if it's just on the wherewithal of this triage group to decide that, because somebody could easily decide, okay, I'm going to sponsor a student to not actually produce anything for 2 years. People do game systems, and they would, that possibility exists. There's also the possibility for people appealing. There's appeal processes. I don't think you want to try and change those in order to introduce this. So what I'd suggest is doing
appealing what?
So the IETF has appeals processes. Anything can be appealed. If somebody is told your work is not proceeding because a student hasn't turned up, they can appeal that, and that appeal can go all the way up through the various kind of appeal processes. You don't want to try and change those processes to take account of this.
So I don't think we are, actually. I think we're just
no. And this this would actually be appealing the working group deciding to adopt something on the condition that it would undergo formal analysis of some kind.
So if the working group has consensus to wait on formal analysis, that's fine. We've done that before, and that's nothing new. The new thing would be is if the triage group wants to make that decision and not the working group.
Nope, that the triage group gives their opinion, and the working group would use that opinion and estimate of the scope of work to decide whether to adopt and whether to bind adoption, whether that document would proceed to a last call blocked by formal analysis.
Okay, I'm getting a bit confused. Anyway, so I as a suggestion, I think I would encourage going ahead and doing this. Don't worry about blocking until we've seen a few cases where the thing has been run and been successful, and then figure out what's the right kind of criteria for having various wait times or whatever. So I'd say, go ahead and do it. Don't worry too much about blocking, and definitely don't try and change IETF process, because then that's a way for nothing to happen.
Yeah, not trying to do that. Yeah, basically trying to put something in place that would actually affect what people wanted to happen with 8773 bis. We said we wanted formal analysis. It went to last call. We still don't have formal analysis, and now we're kind of not sure what we're doing. So this is trying to very closely address that. Arnon?
Hi, Arnaud Tadei from Broadcom. So simply, I'm not a crypto guy, so I'm not going to discuss the content of it, but it's more about the intention. I really like it. I find it really refreshing. I have to transform another SDO elsewhere, so I know how hard it is. I can see already that there are some caution that is expressed by previous interventions, and that's of course. So I imagine that on the way you will find some difficulties, but frankly speaking, persist. It's really worth it because I have the intuition that's going to have more and other benefits as introducing this. Right? And I can imagine the transformative longer term benefit that is going to have. So simply it's an encouragement and please persist, and in the difficulties, you will find difficulties, just stay on your line.
Cool. Thanks. Chris Patton.
Yeah, I also think this is a slam dunk idea. I'm also somewhat concerned about changing IET or TLS working group processes too much. I think what we want to try to do is set the bar initially around the same level that it has been, especially during standardization of 1.3. I think this can go in a lot of different directions. Hopefully it involves like a lot of different people with very different perspectives. And each one analysis is going to be a bit of a one-off, right? We're not going to have like a fully standardized approach methodology for all things that TLS wants to do. So I would just I think we should try to be have just tap the gas. Don't put too much in. Kind of as a motivating example, I think that prioritizing not negatively impacting TLS 1.3, say when we're changing it or if we're adding an extension, we need the highest priority is making sure that extension doesn't negatively impact security of TLS 1.3. I think it's far less important personally that the extension meets its desired goal. TLS 1.3 should be secure enough to should be robust in the presence of kind of bad ideas. That's I think there's kind of two goals to establish there.
No, that's absolutely agree.
I also would love to see people who are doing these analyses involved in the design process. So there shouldn't be a bunch of protocol nerds come up with an idea and build it and turn it into an implementation. They're like, we're ready for security review. Security reviewers should be looped in as early as possible, ideally. And it's also a good way to get grad students involved who want to make an impact. Go design a thing that TLS needs.
Yep. Very agree. And that's kind of why I want to get the first eyes on something around adoption time, not late in the process when it's been kind of percolating in the working group for months or years. I do want them to be involved early on. You never know what amazing ideas or insights or complete game overs you'll get from a different set of eyes from experts like that. Thank you so much.
All right. Hey, so I'll take the chair prerogative here. As somebody who got on a lot of planes and flew all over the world for 3 years with Ecker to develop 1.3, this is just continuing the pact that we have with the security researchers. We're not really trying to do anything crazy and new. So I think, if we say TLS 1.3 was provably secure and we had an extension, we should be able to keep that statement. So let's go ahead. All right, John.
So this is a presentation about large record sizes in TLS and DTLS. It's a draft by me, Hannes, and Michael Taxon. Next slide. So first, why? So TLS is increasingly used in a lot of interface use cases in critical infrastructure, for example, telecommunication networks. And in some of these use cases, the 2 to the power of 14 bytes plain text limitation leads to more frequent fragmentation, and increased CPU and memory consumption. In some cases, increasing this to the power of 16 would eliminate the additional fragmentation. One example that we have, Ericsson has in one of the interfaces here, is where we want to transfer 24 kilobyte datagrams over DTLS. And then you obviously have to do, you have to split it up. And then you have the choice. So, and in some cases you have the choice to, maybe you even need to have some shim layer in between to do the fragmentation. Another use case is RFC 6083, where this is a severe limitation. You cannot transfer user messages larger than this. And there is agreement in the TSV VG DTLS for SCTP design team that large record sizes for TLS would increase performance in several of the proposed solutions. I also talked to Lucas Pardue. Also talked to Lucas Pardue yesterday. He also had said this would increase performance in one of his use cases. So I think this is not for everyone, but I think there's a lot of use cases where this increase performance. It doesn't increase performance super much, but it increases performance enough so that people definitely want to do this. And there's a lot of use cases for that. Next slide. So this slide is how. As you all know, the length field in the TLS records is a UINT 16. So you can potentially transfer records of size 2 to the power of 16 minus 1 byte, or 65 kilobytes. RFC 8449, the record size limit extension, allow endpoints to negotiate a maximum plain text record size that is less than 2 to the 14. This draft, the large record size for TLS, defines a flag extension called large record size that can be used together with the record size limit extension to negotiate a maximum size all the way up to 2 to the power of 16 minus 257 bytes. TLS 103 has an expansion of maximum expansion of 256 bytes. So this is the maximum plain text you can have. An earlier version had some error, and it talks about the ciphertext length instead. That was just an error and has been corrected. A review from Benjamin Kadok discussed whether flag extensions is the right choice. I don't know. An alternative solution would be to have a completely different extension. That are details. I think the important thing is to allow people that wants to have gain this extra performance to do it. And if I were in marketing, I would say, look, a single bit improve makes RFC 8449 4 times better. It's amazing. I did study business. So summary, new proposed flag extension used in combination with the record size limit extension allows negotiation of plain text record size up to 2 to the 60 minus 257. This improves performance in certain use cases of TLS. I think there's quite many of these use cases, is my understanding, but it's definitely not for everybody. I would like it to be adopted. Ecker?
So I've read this draft. I think this is a worthy goal. I'm a little uncertain with the spelling of it. As David Ben would say, whether it would be best to have whether it's best to have a flag or whether it's best to have some other extension. I'm sure you're not hard over on that one or the other, but I think it'd be fine to adopt it as is and then try to sort out what the best spelling was. And I'm not saying this flag is bad. I just haven't really thought it through enough. It makes me feel a little twitchy, but that doesn't mean that instinct is right. But I think we should adopt it. I think it seems like a worthwhile idea.
Thanks. Kyle?
Just speaking as another, I think, fairly large user of TLS inside data center networks, I think this is useful work. I don't think there's any kind of situations where it makes a massive, orders of magnitude difference, but anytime you can get more performance is helpful. So I do think we should adopt this. As far as the details, I think at first glance, I'd go on the side of a separate extension, but that's something you can figure out later.
Alex?
Hi, Alex Chernohovsky, Google. I was wondering if you actually had some of the performance metrics that you say are improved, because I just went and logged into my workstation and ran OpenSSL speed, EVP, AES-128 GCM and looked at the block sizes, and there's diminishing returns after 1K. 16K and 8K got the same result. So I'm a little bit confused as to why we should adopt this on the performance grounds if we don't have performance data. Thank you.
Stephen?
I seem yeah. I guess I also wonder what it would what it would break if somebody implements this badly. I mean, I think getting some more experience with it. I also wonder have you thought about how would this have any impact on traffic analysis for the kinds of applications that you think it would be used for? Just wondering, if people are making bigger packets that better match the application there, does that make traffic analysis easier? It might be a concern.
Yeah, I hadn't thought about that. Typically, 5G core interfaces, I don't think traffic analysis is a big thing. Other use cases of this might, of course, be somebody might want to do traffic analysis off. I haven't thought about the implications for that, but yes, there any difference, of course, makes affect traffic analysis. Yeah,
sure. But just to be clear, I'm not opposing adoption.
Martin
Thompson. I've got serious concern about the spelling of this one. I think Eka said similar things. I also share Alex's concern about the performance thing. I know that when we did HTTP2, there were a number of people who were concerned about our 2 to the 16 limit at the time, and showed evidence that having a larger frame size would be more efficient for their application, which was interesting at the time. You might be able to go through the archives to find some of those things. But to Alex's point, it's diminishing returns over time. So there is that. I did make a suggestion in chat that I think is semi-serious, that if you're going to do this, a 4 times increase in size is pretty marginal in terms of the benefit. You should probably look for something that will allow you to get to larger sizes even still. 1 megabyte would be kind of crazy in some senses, but if that's what the sort of performance gain you're looking for, it's possible with a small extension, but not a flag.
Okay, so the suggestion would be then an extension that extends the length field in the record, if I understand you correctly.
My suggestion was to have a record size scaling parameter, so you can scale the size of the record size field, shifting it left by any number of bits. Yes, okay. I know Scott's finding that disgusting, but that's the sort of thing that would be possible here. And of course, blowing the top off the limit, the 2 to the 14 limit, at the same time would be acceptable as well.
Okay, yeah, then I understand. Thanks.
All right, Ecker.
Martin, don't sit down. So in your world, if you had something that was not an even, say you shifted by one, if you had something that wasn't an even, you have to pad to make that work, and you have to keep padding until you got to an even block size.
Yeah, that's right.
Okay.
And to Stephen's point, you get better traffic analysis properties out of that.
I'm
It's
not
a
necessarily
small
arguing.
price to pay.
I just want to make sure we had a clear idea of what you're proposing. Thank you.
I think I agree with the point that if we're going to do this, we should make it so you can go further than just like a step size of like 2x or 4x bigger. One other thing that this can make possible is more like in place encryption of a large buffer without having to constantly splice in the tags.
Thanks. All right, so what I think we're going to do is, it looks like we have some interest in solving a problem that's got some shape, with some reservations about the motivations, et cetera, but there seems to be a way we can do this. So we'll work with the authors to figure out what should go in the draft that can be adopted, with the understanding from the working group that it may radically change what first gets dropped. All right, so we're actually going to work on it and go from there and see what happens. There is also no guarantee that we're actually going to publish it out of the working group. So just so everybody's on the same page, so we can get something adopted as opposed to having the fight before we adopt it and then just having no discussion in the working group. Does that sound like a plan?
Sounds great to me.
Well, I knew you were going to say that. Anybody else? Okay, great. Next. Okie dokie. Who we got? Flags. Jonathan. Thanks to your comms people for coming through.
Hi, everyone. These slides are almost identical to the slides I presented last time, but the last one's different, I promise. Next slide, please. So basically, the problem I'm trying to solve here is it's very, very hard for us to be able to distinguish web crawlers specifically. So bots that are not accessing dedicated endpoints, bots that are accessing eyeball websites. We usually do it through user agent and IP block, and that's really bad. It doesn't work very well in practice. Next slide, please. But yeah, so using user agent and like public cloud as your thing means it's quite easy to forge, and bots generally can pretend to be other bots. Next slide, please. We'd like to use certificates because certificates work well, but if you send certificates to eyeballs, they have no idea what to do because they get a show us the certificate and there's no like anything in the browser telling them what to do. Oh yeah, the other options add an extra RTT, so yeah. Next slide, please. Oh, sorry, I just said this. Next slide, please. Yes, so proposal. Set a single bit in your client hello that says, I have a certificate configured. Doesn't say anything, doesn't say you have to ask me for it. It just says, I have a certificate configured. If you want to ask for it, I'll send it. So I think this is the cheapest and easiest and like simplest possible solution. Next slide, please. Does anyone have any questions? I have two working interoperable implementations, one in C, one in Go. I just open sourced the Go one like 4 seconds ago. You can find it on my GitHub. I will put a link in chat. The C one is still pending. There's a demo server. If you happen to have a client, say the one from my GitHub, you will be able to ping the TLS flags.research.cloudflare.com. And if you set flag 80, it will ask you for a certificate. Can we adopt this?
So last time we had some interest, but there were some questions that abounded. And so we approached Jonathan and said, hey, do you want to give it another shot? Trying to maybe narrow the scope a little bit, which is, I think you've done that. So I guess I'm curious to know if there's any rampant objections to trying to have an adoption call for this particular draft. And I should note that with multiple interoperable implementations, the TLS flags draft itself can be released and move on its merry way, but it'll probably move at the same rate as any actual flag that gets shipped with it. So, all right, I'm not seeing anybody get to the microphone. Oh, hold on.
There is
a couple on the queue. All right,
Eric.
Yeah, I don't really have a strong feeling with this document either way, but I would like to see more than rampant objections to an adoption call. But it's the enthusiasm for the document. We have a process of registering code points that does not require an RFC. So like we have plenty of work. We shouldn't take on work unless people actually want to do this. And again, I'm not saying we shouldn't do it. I don't really have an opinion on that.
Okay. Well, again, I'm going to take it to the mailing list and we'll see what kind of responses we get. And if we get crickets, then we know the answer.
So I guess the other question is, how do we select the code point? Because I selected flag 80, which means I sent 11 bytes. Obviously, a lower flag is better, but depends how common it is.
We can figure that out later.
Yeah. Oh, you mean I get one? Yes.
All right. Okay. So again, for the summary for the notes, I'll take that to the list. Thank you, Rich, for taking over for Hannes as he presents.
Test. Okay. Yeah, I've received some advertisement from in previous presentations already, so thank you. Yeah, so I'm going to talk about the extended key update, which some of you have seen a 0.0 draft version being published right after Christmas, and immediately we have gotten some response. Thanks for spending your Christmas vacation reading the documents. That's excellent. So a little bit of history. So when the TLS 1.3 specification was developed, or the protocol was developed, there were a couple of features removed, others added, and one of the features that was removed was renegotiation, and which in particular had an impact on two aspects. One was the ability to do key update, and also the second one was post-handshake authentication. The post-handshake authentication is available in TLS 1.3 from the server to the client, and was later added by Nick in both directions using the exported authenticators. And I will mention that because I will get back to the specific design in the next slides. The key update is also, as you know, available in TLS 1.3, and it just it rolls keys. It doesn't provide any forward secrecy. Next slide. So as John mentioned, there are some use cases where long-lived connections with TLS are common, obviously not the web use case. And here are the two examples. The design team has been mentioned in the TSVWG, which was about securing telco traffic. Another scenario is industrial IoT, where you have things like power systems, where you have these long-lived connections. And also, increasingly, we see some of the TLS sort of secure traffic, IPsec secure traffic being replaced by TLS. However, that requires these two extensions, the post-handshake authentication, which is already available, so that's great, but also a key update, which uses forward secrecy to force an attacker to do dynamic key exfiltration. Next slide. So we published the 0.0.1 draft, got feedback, totally changed the design based on that feedback. So I'm going to talk about the 0.1 version, which I submitted in time for the deadline. Thanks to all of those who provided feedback. So it has three so the design space is surprisingly has a couple of options, or it's larger. And in this specific design, it has three principles. The first one is it follows the key update message, which is a one-shot message from the TLS 1.3 design, which triggers the key update. It's a regular post-handshake authentication message. For the forward secrecy, we decided to reuse HBKE as a KEM, which also gives us the possibility to use or to benefit from some of the work that Scott has been talking about earlier in this meeting, the hybrid exchange with the combiner, which was also something that was brought up on the mailing list, was not something we focused on in the design team work. And then it borrows or is inspired by the design from in the exported authenticators, which uses, if you remember, a quite interesting design where the payloads actually exchanged at the application layer and then made available to the TLS stack, or the outcome of it. And as a consequence of that design, the HB key payloads and the public keys that are exchanged, they need to be exchanged at the application layer. So that's simply what the exported authenticators does and what this then inherits as a consequence. Okay. So there are nice diagrams in the document, but the ask, or my ask to the group is to provide feedback regarding the use case, whether you think that this is a useful use case to have forward secrecy with a key update, whether you have specific or more opinions about the solution design, specifically about the use of the application layer design as the exported authenticator does, which we switched to after we got the feedback that it obviously the messages required changes or additions to the state machine. And yeah, and then we obviously are seeking to do this work in the TLS working group and sort of with the feedback from the group. Scott, where is he? Oh.
Okay, two comments. My initial opinion is that it'd be nicer if this would be done entirely within the TLS protocol level, and unless I'm misunderstanding your use of application layer, you really don't want the application layer to actually get involved, other than possibly saying, "Oh, go rekey yourself."
Okay.
Since I'm up here, another comment I had is it appears that your design, either the client or the server, could ask for a rekey. One of the things you have to be careful about is if both happen to ask for it at the same time, something sane happens. That is, say they don't get out of sync or anything. I didn't see that called out anywhere in your draft.
Okay. On the first point, yeah, so that's actually, I think, why I want to bring this to the TLS working group. So it's not just purely at my discretion to change the design forwards and backwards. In the 0.0 document, we actually did the design TLS messages, and then the feedback was, why do you do it at the TLS message when I don't want to make any changes to the TLS state machine? And so that kind of inspired this work. Also, because we need the bundle of the two features, the key update plus the post-handshake authentication, which happens at the application layer. So it's kind of, we have to do something at the application layer already anyway because of prior work in the TLS working group. So this is not my construction. It's essentially work that the group has already done so far, which is what it is. Okay. But point taken. On the second aspect, yeah, happy, like it's in some sense for that design, it's a 0.0 version. It's not complete. It's a proposal, but so definitely have to cover that too. I agree.
Okay, thank you.
And thanks for the initial quick feedback.
Hi, Hans. So I only saw the second version of your draft quite late last night, your time. And I have just some general concerns about the changes you've made between 0.0 and 0.1. So in 0.1, I think it was also present in 0.0. When you're talking about forward secrecy, I think what you're what you mean is like post-compromise security, because the key update that's currently in TLS 1.3 already has forward secrecy. So when like you do a ratcheting of keys forwards and you delete the old key, you get security against compromise in the future. But I think what you want is kind of the opposite, which is where if I get compromised now, I would like the attacker to be kicked out in the future. And for that, you want post-compromise security. That's like the public key rekeying. Secondly, like in the draft, I think the way you've described it, you know, it's quite generic as to what could happen at the application layer, but the draft suggests using like an ephemeral static Diffie-Hellman exchange or an ephemeral static chem, where the static chem comes from the server's certificate. And in general, that won't provide either PFS or PCS, because in that situation, the attacker will have compromised it at some point, and then either later or future, they'll have access to that private key, and they'll be able to go back and decrypt those key exchanges to access all the past keys, which will break that property. And like similarly with Scott's kind of concerns about mixing at the TLS and application layers, one thing that came to mind that might go wrong there is that you might have a situation where there's a middle box between your two peers that want to do this kind of rekeying. And at the application layer, that middle box is potentially transparent. It's only at the TLS layer that that middle box is going to show up. So in that circumstance, the applications aren't necessarily going to realize that they're not in the same TLS session with each other. There's going to be a middle box that doesn't have access to that application layer keying material. And so the rekeying can't happen in that circumstance. So I think for that and other reasons, this is really the kind of thing that if you were to do, you would want to do entirely within TLS. And to my mind, your 0.0 draft was quite neat and maybe not, I'm not sure about whether overall its complexity justified the end goal, but it did seem to me like if you were going to do this thing, that might be a better way to do it than some of the changes that have been made.
Okay. Yeah, thanks for the feedback. John, I think you jumped up when it came to the forward secrecy topic. Is that correct, or did you queue for the microphone?
I'm next in queue.
Okay, that's great. So you brought up a couple of points. So the forward secrecy, initially we used the term perfect forward secrecy, but that terminology changed with some other RFC, which number I forgot. What we want to do is a kind of a Diffie-Hellman so the elliptic curve Diffie-Hellman for elliptic curve cryptography. So that this is obviously more than what the TLS 1.3 RFC does in terms of features. The key, the recipient key that we use in HBKE is not from the long-term certificate. It's actually a public key that was exchanged on the existing handshake. So in that sense, I think that's kind of different than what you described. The reason why we switched from the regular sort of Diffie-Hellman was actually had a couple of reasons. First one was the problem that in the exchange, we then kind of stalled the transmission of further data till the completion of the exchange, which people didn't like. And so we wanted a one-shot message, which required us to use a construction like HBKE, a semi-static Diffie-Hellman. So that's something we had to make. On your point and your preference for the for using the TLS messages, I think I take that point. It's like apparently there are different preferences.
Yeah, so sorry, so just to comment there and clarify maybe, if you're trying, so I think the thing you want is post-compromise security rather than perfect forward secrecy or forward secrecy. The TLS 1.3 key update already achieves forward secrecy. I agree that you want something different to that, but I think the thing you're looking for is post-compromise security. And then, yeah, in the draft, to achieve that, you need to go and generate a fresh key on both sides and then have them both use it. And then you get PCS from that point forwards. if you've got any kind of static key that you're catching, say from earlier in the connection, you can't get PCS past that point, because the attacker can go back to compromise you at any point up to the last time you generated that fresh key. So I think, you know, in that sense, there's always going to have to be some kind of interactive handshake or key exchange to trigger a new round of PSS. Yeah, thanks.
Yeah, definitely. I can change the terminology. I try to stay in line with what IK version 2 has been using, because it has the same feature, or not the same, but a similar feature. But I'm happy to change that to whatever. Thanks for the feedback.
John Matson, Ericsson. I'm supportive of the use case. I think there might be several situations where doing frequent resumption is problematic. I thought the 0.0 draft was a very good start. I think the 0.1 draft goes in the wrong direction in several ways. First, using application layer, authentication and key exchange is very different. I think using an application layer here adds complexity. I would not like my keys to be shared with the application layer. And also, this requires that you can make changes in your application layer, which I think is not at all always possible. So I think this needs to go back to the TLS layer. Then second, as pointed out by Dennis, now you're doing static ephemeral diffie-Hellman. I think you need to go back to doing ephemeral key exchange.
Okay,
I would,
I'm actually doing that. It's just it's unfortunate wording, because the semi-static here, the static is just from the name, the way how the mechanism is proposed. But since I'm exchanging the public key in the exchange in the message beforehand, it's kind of ephemeral.
The connection could be, in my use cases, the connection can be longer than the certificate lifetime.
But it's not, I'm not using the long-term certificate as the static key. That's important. I'm actually exchanging an ephemeral public key up front, which I then use, the recipient sends the ephemeral public key, which I then use to...
It's ephemeral if you use it once.
I'm using it only once. I'm only using it once, but...
that was... If you do that, then it's fine. I would like to API do rekeying and then TLS do the rekeying for me. Then a minor thing is HP key. I don't really understand the change to that. Like chems, PQC chems in TLS are reusing the already, like code points and already deployed are using the key share. It feels to me that going to HPKE would add burden on the implementation. You had to add a lot of code, but that's I can live with HPKE if it's done on the TLS layer.
Yeah, on the first point on sort of switching the style to the application layer, at least I interpreted the feedback I initially gotten that would be the preferred approach, but apparently misinterpreted that signal. So yeah, I have to go back to where I came from. Damn it.
Jonathan Hoyland, Cloudflare. So the reason I actually do like the application layer style is because, well, I think both of them actually break the security proofs from Tamarin at least, which, like, it's a lot of work to redo those proofs. It's doable, but like it takes forever. This is very similar in shape to the extended key schedule draft I proposed pre-pandemic, like a long time ago. But the entire point of the shape of that draft was it doesn't invalidate the Tamarin proofs, and I think it achieves the same effect. Yes, the other thing I wanted to say is, so the way this is implemented is it just modifies the application traffic secret, but doesn't modify the resumption or exporter key secrets. And so the security guarantees of those get out of sync with the application security keys guarantees, which just like requires a whole new model for understanding.
I don't think so. Because they get out of sync already with TLS 1.3 as well.
They have the same guarantee because they don't do it's just like a hash iteration, and so they have the same property.
I'm not sure because I think that was one of the change that, and I'm asked that question on the mailing list. I think it was David Benjamin who responded to that. It was kind of a side effect that in with the exporter mechanism that barely anyone noticed, I guess, that the key update changes the key and the exporter exports what it was initially negotiated. So I'm not sure that was really. So I would double check the proofs again whether that was really taken into account.
So imagine this like scenario. You get some new extra security property from your application traffic secret. I don't want you to have that, so I just like kill the connection and force you to do a resumption. You don't get any security benefit because the resumption hasn't had that increase of buffer forward secrecy or PCS, whatever the guarantee you want is. Right. So whatever guarantee you get.
Well, I didn't want to provide that property. I want to keep it simple, and then when you go back to resumption, you go back to the key you originally had. You're not going to sort of like do something else. So I think you have to live with that. At least in my design, but
right, that's what I'm saying. In your design,
of course, you may not like that design, but
in your design, this only gives you security benefits if you're not under attack. So it's the seatbelt that only works when you don't crash.
No, I don't agree with that. I think, we need to discuss that.
Yeah, for sure. We can take it to the list.
David Benjamin. The reason you don't want to update the exporter secret and friends is that you cannot have both. You have to we either have to sacrifice transparent rekeying where the application protocol doesn't know what's going on, like where it's like transparent to the application protocol, or we have to leave the exporter secret alone because otherwise the application protocol won't know like when the exporter secret has changed. As to this draft, I think this is kind of overkill. Like the use of HPKE could just be key shares. The exporter authenticator stuff, I suspect that might be a misinterpretation of something I said that was not the intended direct. Like this exporter authenticator doesn't make sense here. The problem with the original draft was there was an issue with like the order of the messages and like if they flowed while application data was also flowing. There was some sketch of a solution on the list with 3 messages rather than 2 messages, which would have completely solved this problem. I don't think we should do something exported authenticator like that. Sounds like it would just make everything annoying.
Well, I like the idea of the exported authenticator because I have to use that already anyway. And so it would be one style of design. I like that sort of uniform design in that sense. I don't know why people are now so much against the exported authenticator and approach, given that it has been done in this working group. But I'm happy if people say, oh, we actually don't like that design and fall back to the other one. I'm actually not married to this specific design, but I interpreted the feedback that this is something that is desirable, but maybe not.
So
apparently not.
I think it's a question of whether this is in the old TLS 1.2 renegotiation mechanism, renegotiation was like half visible. It was originally like it's generally implemented as transparent, but it's not really, and that caused a problem.
Yeah.
So in TLS 1.3 key update, it's not something driven by the application. Sometimes you have APIs to trigger it, but at any point TLS can just unilaterally decide to send a key update, and the application protocol doesn't have to know.
It's not like you still have to. So you still may want to have the application do a trigger key update. So sort of like there's nothing in the specification that says only the TLS stack is allowed to do that, or only the
Right.
application drives it?
The application is allowed to drive it, but the question is whether it is required to be in the loop, like whether it is an error to ever trigger key update without the application knowing. And it is currently not an error to do that, which is a good thing, I think, because it means the TLS layer can just sort of like have automatic rekeying, and we don't need to patch every single application protocol one by one.
Right.
The reason exporter authenticators make sense and this doesn't apply there is that authentication is inherently application dependent. Like if I suddenly add a new client cert to an HTTP2 connection, like what in the world, I need HTTP2 to know about it, or I can't even know what that means. But HTTP2 doesn't really care about the encryption protocol. It's just like TLS, you solve this for me. And if if TLS thinks, oh, it's useful to, improve post-compromise security for long-lived connections by swizzling in new secrets, then like, yeah, it's cool, we can do that. But if we want to build something like that, then we can't use an exporter design, because an exporter design assumes the application is in the loop. If you want to build something where the application is in the loop, we can do that too. But I don't think it's necessary here. And so if we can avoid them being in the loop, it seems just simpler for everyone.
Maybe, yeah. Like I think the exported authenticator was very much driven by the web environment, and maybe some of the machine-to-machine communication is different. But I feel the mix, sort of like now in a solution that fulfills the requirements, I now need to have both. I need to have something, an extension that uses the exported authenticators plus something, for example, a key update at the TLS layer.
I mean,
because I have no alternative if I want to have mutual authentication in a post handshake style, I can't just stay at the TLS layer today.
Right. I mean, because authentication is inherently application visible. I'm probably spending too much time on the mic, so maybe we can do this offline.
But thanks for the feedback. Very helpful.
I think the problem here makes a lot of sense. I'm pretty concerned about the amount of complexity we'd be adding by trying to do this at the application layer. I think we should look at other options that utilize the existing resumption mechanisms. So you can imagine a situation where we have like a defined closure alert that says close the TLS connection and immediately start a resumption PSK handshake on the same connection. That would vastly simplify this. We wouldn't have to worry about like exporter secrets getting out of sync with security properties. And we wouldn't really be cryptographically changing much of anything at the TLS layer. So I think unless there's a really strong reason why an approach like that wouldn't work, that would make a lot more sense to me.
Yeah, so in the meanwhile, I got the point that nobody seems to like the application layer style. I think that was pretty clear. If there's one thing I take away, then it's that one. On alternatives designs, definitely. So if we could avoid having interruption of the communication, that would be good. If that would be a way that would make that possible, and at the same time having a simpler design, I'm all in for it. Thanks for the suggestion.
All right, so we'll see a revised version of the draft that goes back and gets changed. So thanks. All right, Deirdre, you're up. I'll unlock the queue and let you take over.
All right.
There we go. Cool.
Where in my document? There's my document. Awesome. All right, so this is maybe a little spicier than formal analysis triage panel, but this is a pretty simple proposal, which is adding pure MLChem as a new named group for TLS 1.3, not in hybrid mode, but as just a standalone MLChem. And in the document, I only have MLChem 768 and MLChem 1024. Just because, but I'm not married to that. So honestly, this kind of fell out of looking very closely at the hybrid design that was discussed by Scott Fleur earlier. And what it specifies is that you can have your traditional cipher suite named group, such as P256 or X. In a hybrid,
Uh-oh, you were bouncing in and out there. Oh, and we lost her. It's coming back.
Let's see. Am I back?
Yep.
You're back.
Okay. It explicitly names specific hybrid combinations. The only things we have listed right now are what was Kyber at the time and will eventually turn into MLChem with P256 and with the X25509. The design kind of implies that you should be able to do the other side of the hybrid, which is MLChem, I think it's 768 for both of them, by itself. And so that's what this does. It writes down MLChem 768 and MLChem 1024 as their own named groups in a very similar fashion. This is also partly motivated because this will be, according to all the kind of draft indications from the U.S. government about their security standards for their CNSA 2.0 compliant vendors and communities that they serve, that MLChem 1024 by itself will be a fully supported key agreement, not in hybrid mode, but by itself. And there's been a lot of signaling that even parties that are supporting protocols that are in hybrid mode they might get an exception, they might only have that solution, will be extremely motivated and consulted to move to pure PQ only by 2030, 2035, depending on the application. So if that's the kind of direction that at least a non-trivial segment of TLS users are heading in by compliance and regulatory issues, I wanted to just write it down. So I've written it down. This is basically the meat of it. Just write down some new named groups. I picked some numbers because they seem nice. I'm not married to them. And this is just repeating a lot of what is in hybrid design. The way that chems work with hybrid design with this sort of key exchange is the client does an ephemeral chem key pair generation, shares its encapsulation key as part of the client hello, sends it over to the server. The server, if it supports this, will generate this, you can call it the seed of the shared secret, and encapsulates that to the client's ephemeral key pair, and sends that ciphertext back in its server hello. And then both of them on both sides will decapsulate. The server has access to the derived shared secret through the KDF of MLChem already. It has a shared secret, and then the client will receive the ciphertext as part of the server hello, and decapsulate that to its copy of the shared secret. And then this is how we shove it into our lovely TLS 1.3 key schedule, and it just goes right in there. Instead of the elliptic curve Diffie-Hellman shared secret, it's the shared secret that comes out the back of MLChem. And you're done, and you don't even have to think about, if people are in the CFRG talk earlier, you don't even have to worry about any of these binding properties I talked about in there, because TLS 1.3 is all sunshine and rainbows. All the ciphertext and the encapsulation keys and everything is already hashed into the transcript up above, and so we can do whatever we want with this chem shared secret and not think about anything else about it. And that's kind of the meat of it. This was discussed on the list, so some frequently asked questions. Should this be recommended equals yes. I don't think so to start. It is kind of fresh and new. I thought it should be available. Do I think it should be recommended? Maybe not yet. I'm not strongly holding strong to that. Someone asked, what about we also do PQ signatures at the same time in the same document? I'm like, we don't have to bite off the whole thing in one go, but also just slotting in MLChem for key agreement is easy and clean. We don't have to worry about sizes and all this sort of stuff. And like the fact that there's like 7 PQ signatures in a modern TLS 1.3 handshake with all the, there's the PKI and there's there's certificate there's a whole bunch of signatures in there. We don't have to touch that yet. We can do that as a separate document. So that's my opinion on that. I've heard a lot of commentary about, isn't this too early to have a PQ only option? And I would basically say no. And I'll kind of talk a little bit more about this in the next 2 points. Some people say, well, we have hybrid, and like we're going to ship hybrid, and Firefox is shipping it on nightly, and Chrome is about to ship it. So why? And it's like, well, there are a non-trivial number of parties in the world that use TLS that may never use hybrid, and they may only have enough in them to do one PQ transition. And there's a non-trivial number of that set that will be required to go to PQ only very soon, like within 6 or 7 years. So I'm trying to look squarely in the face of that world and just sort of like treat it as if it's real, as opposed to just sort of ephemerally out in the world somewhere in the future, and not relying on the fact that we have hybrid, because there are some people who can't rely on hybrid. And then a lot of, I don't trust PQ crypto. It's too young to rely on it by itself. And I wanted to go look at the timelines of, say, elliptic curve adoption to sort of compare to where we've been. Elliptic curves were introduced in the literature in use in cryptography in 1985. There was a Certicom curves that were published in, I think, 1998. There was proposal to be used in TLS in the working group, and it was adopted by the working group in 1998. And then the NIST curves were published in 1999, and that document for use in TLS became an RFC in 2006. TLS 1.3 making ephemeral elliptic curve Diffie-Hellman the only solution for key agreement really pushed the numbers up into the high 90s for, who is using elliptic curve Diffie-Hellman for key agreement. But it took some time, but not too much time, to go from a NIST standard to fully supported and recommended, I think, in TLS. It took about 7 years. A little bit over 7 years. Crystal's Kyber was published 7 years ago. This NIST draft is about to be a real FIPS, a real boy. It's going to be FIPS 203, probably in the summertime. And so if this document were adopted now, it's about in line to the latency that elliptic curve Diffie-Hellman had respective to its other standards at the time. But also, we don't live in the same world where elliptic curves were adopted in TLS. We know a lot more. We have a lot more kind of analysis, I guess, about this stuff. And this is not like lattice cryptography, period. This is, one specific scheme, yada, yada, yada. I think this is not being too aggressive, but it also, I think we could afford to be a little bit more aggressive. And I'm not suggesting that we are. So that's kind of my pitch, and I'll take questions. Rich?
All right, guys, just we got 12 minutes, so.
So I'm actually a little concerned with, as Tolkien would say, do not go to the IETF for answers, because they will both say hybrid and PQ only. And so, like, that's kind of what we're doing, right? Everywhere else in the IETF, we're doing hybrid. And supposedly
there's some LAMPS proposals that are not hybrid.
Yeah, okay. I'm just concerned that we're not, we all are kind of scared about this brand new thing. I remember Dan Bernstein posted a timeline of all the finalists and how they've been broken in the past. I'm a little, don't shake your head no at me.
I'm not shaking my head at you. I'm shaking my head at DJB.
Yeah. At any rate, it's I'm not saying it's too fast, but I'm saying it's not fully consistent, and that bothers me a little.
All right, I'm closing the queue. There's like 12 people in it.
John?
Yeah, thank you. I'm supportive of this work. We're planning to offer hybrid as the default in all our product, but we would like to offer MLChem only to customers that want that. I think TLS should just register all the variants that NIST standardizes. I think all the 3 MLChem and then bike or HQC or classic McLS, whatever comes next. And let the market want what it. I think this is super simple. There's no changes. There's not much. I think just register the code point, register them as recommended equals no. I don't think any RFC is needed. This is just code point registration for new groups. Yeah.
Eric.
It's me, I think. Yes. So yeah, I think I'm sort of largely in agreement with John Mattson about the outcome, which is just the code point based on the draft. I don't think we need an RC. I guess I'm sort of I do want to make sure 2 more substantive points. One is my sense. There's the issue you raised of sort of reuse of the Diffie-Hellman shares in the hybrid draft. I'm not sure I think that's a great idea, frankly. But I will say one thing about it is it's not required the other side to notice. So it's really only complexity people which is to bear it. So that makes me feel somewhat better about it, even though I think probably it's a bad idea. Second, I guess I'm super unmoved by what CSNA 2.0 says. They can say what they want, but we should make decisions that we think are the right decisions. And if people who, and given the code point can be registered, if people want that, they can have it. But I think the IETF should endorse things that we think are good. So I guess I don't feel qualified to really have a strong opinion about what's good and what's not. Though I'm probably a little less bullish about than you are. But I think that again, we should make a decision based on what we think is right.
Yeah. On that previous one, I made some suggestions, I think, I don't know if they've been pushing data tracker for hybrid design, that made it very explicit that you can do the key gen, the ephemeral key gen for hybrid that is sharing offerings in the key share in exactly 2 ways. You generate one thing once for your elliptic curve Diffie-Hellman and your chem, and you share it, or you have them completely independent. You can have and basically made it very explicit how you can, but you're not required to share key gen. So you only have to do 1 key generation or whatever. But if you want to, you can just generate everything on the fly willy-nilly and not do any sharing if you want to eat that cost, which may be significant depending on your setting. That was a bit smushy from the initial thing that I looked at, but yeah, that's in there. And then, yeah, this is not necessarily we want to comply with CNSA 2.0. For me, it was very much they trust it that much. I trust it. And I've been up to my neck in MLChem for months and months now. I trust it enough to make it an option. Not necessarily recommended, because I think Ikir mentioned that on the mailing list. I do think it should be an option, and I figure we got to start somewhere. So, Scott.
Scott Fleur, Cisco Systems. I strongly support this work, even though I'm a co-author of the hybrid draft. As for supporting only hybrid, I would disagree that with the previous stalkers that just because the rest of the IETF is going towards hybrid doesn't mean that we are mandated to. As for not trusting MLChem, well, there's nothing that says you have to use this draft. If you don't trust it, don't use it. Thank you.
Hi, Stephen Farrell. And on the opposite hand, I think this is a terrible idea. Having optional things that you say exist but people shouldn't or don't have to use, I think tends to turn out badly for interoperability and for possibly for security in general cases. So I think the best solution here, I think, would be to add a note to the abstract of this draft saying never do this, but if you ever did, here's how you can. I think you can get a code point, that's according to the policies. But again, I think having that code point would not make the internet better. I think it might make it a little bit worse. So I think
I'd encourage you to decide not to do this.
Hey, I'm Quỳnh Đăng at NIST. On the official level, we and I personally myself, we are fine with hybrid and a standalone post-quantum. And I do like the word that we've been using in this talk is the word trust. We're not talking about crypto analysis, the latest results, and what is the security of MLChem based on. And we're not talking about that here. We just, the only thing coming from this is about trust, about your own feeling, your own feeling. So the feeling, my personal feeling should not force on everybody else what to do or not to do. It just should be me. So if you don't feel happy or feel good about it, then just don't use it. But if other people, they feel strongly confident about it, then don't try to hurt them or force them. Just let them live with their trust. So I support both.
Cool. Thank you. Martin?
I won't be long. This is a distraction. I'd rather see this go as an individual draft than continue in this working group. For all the aforementioned reasons, not quite as strong as Stephen's, but more in line with those expressed by Eka and John.
David Skenazy. I think on the FAQ slide, one point that perked my ears up was the adoption takes time, so we should start now. The adoption takes time. We don't start the clock when the RFC is published. We start the clock when people start caring. And so I wouldn't use that as an argument to publish this sooner. From my perspective, it sounds like there are people in the room who want this, so definitely get a code point, but we don't need an RFC for that. So I would +1 to what MT said. We should get the code point, have a draft that doesn't need to be published to have it so people can use it. And then if at some point we decide we want to recommend this, then we should publish it as RFC.
Okay, we surprisingly drained the queue in time for the end of the session. Joe and I will confer and we'll get back to y'all about what to do. But yeah, it does seem clear like there was a way forward to actually get a code point. So it is, and I've seen a couple things fly by in the chat about, could we do ROT 13? Yeah, if you want, you just put a D next to it. So I mean, everything can get registered. The bar is low. So or high, depending upon how I go. Because I look at this as the 1024 variant as the people who like to protect against aliens. So and I'm not a cryptographer, so yeah. But thanks again, everybody, for a lively session. And again, thanks for taking notes, Hannes and Rich. And we'll see y'all next time. Ciao.
Bye. Thank you.
All right. 15 minutes to get lunch. Another. Yeah. Fair enough. Yes. But I mean, at the end of the day, the minute it's done, if you get a point, then
June-ish, whatever that time counts. Yep, get it the next time.
Yes, literally the next day, because we know the people. Did you find some other place that had a quicker lunch?
No.
Option?